Hello friends, in this session we'll be talking about congruency and congruence of triangles. So let's first of all see what do we mean by congruency. Now, two figures are said to be congruent to each other when they are equal in all aspects like shape and size. In other words, if two figures can cover each other completely when placed one above the other, then they are congruent to each other. Now, say for example, we have two circles of same radii. Now, we may take, say for example, these two centers we take. The centers are different, but we draw the circle of same radius. So if we have this one circle and if we have the other circle of the same radius, even if they are placed at two different places, now if we put one above the other, they will completely cover each other. So these two circles are congruent to each other. Similarly, if we have two squares of same side, so supposing we say that the square of side 2 centimeter. Now if we have two squares of 2 centimeter each, then they will always be congruent to each other because they are exactly same in all aspects of shape and size, and they'll completely cover each other. Now, an example of this would be we are taking these uniform regular shapes, but if we take any other shape, now an example could be if we take a plain paper, two plain paper and put one above the other, and then cut any figure from that set of papers. Now the two shapes which will come out from the two papers will be congruent to each other. Now this is not just true for the regular shapes that we've drawn here. Now let's understand what do we mean by transformation of figures. Now to find out if the figures are congruent, we can perform transformation of the type rotation, reflection or relocation, but of course not resizing them. And we can perform this transformation on one or both the figures to again completely overlap one over the other. Now if it happens, then the two figures are congruent. Now again we'll take an example of a square. Now this is one square, and now I put another square of the same dimension, say 2 centimeter side. Now I place it like this. Now are they congruent to each other? Now just looking at it, you may feel that these are two different shapes. But if we rotate one of them, say for example we rotate this clockwise and we bring it in this kind of a, bring it to this form and then place it over this, we'll see that these two are congruent. So we can actually perform this transformation on either one or both the figures, and then if after this kind of a transformation, if they overlap each other, then also they are congruent to each other. And if they don't overlap each other, then they are not congruent to each other. Now we'll take this example. So this is one shape that we have. This is another one that we have. Now they are similar kind of pentagons, but if we try to place the blue one over the mustard, these will not overlap completely even after transformation. So these are not congruent. But if we take this green one and if we try to superimpose this on the yellow one, the mustard one, we'll see that these two completely overlap each other after transforming either of them or both of them, and then they'll completely cover each other. So these two figures are congruent. So green and yellow are congruent, but the blue one is not congruent to the other two, although it is a similar type of a pentagon. Now let's talk about congruence of triangles. How is this concept of congruency used in triangles? Now if two figures are congruent, then their corresponding parameters will be equal. So if we are saying, say for example, this shape is congruent to this shape. Now we are saying this side overlaps with this overlaps with this overlaps with this, and this overlaps with this. So if these two figures are congruent, we can say that their corresponding sides, corresponding parameters would be equal, because now we can say that this angle will be equal to this angle, but we can't say that this angle would be equal to this angle. So this would not be true, because only their corresponding parameters would be equal. In case of a regular figure like square or an equilateral triangle, you could say that all the parameters are matching, but for an irregular shape, only the corresponding parameters will be equal. So generalized statement would be that if two figures are congruent, their corresponding parameters would be equal. Now say for example, we have these two triangles ABC and PQR, which are congruent to each other. So then their corresponding parameters would be equal, as we said. So in case of triangles, we call this as CPCT, which means corresponding parts of congruent triangles. CPCT is a standard terminology which we use to say corresponding parts of the congruent triangles. Now in these two triangles, as we said, are congruent, then we can say that AB is equal to PQ, BC is equal to QR, AC is equal to PR, and angle ABC, which is this angle, would be equal to angle PQR, which is this angle, and angle BCA, this angle, would be equal to angle QRP, and angle CAB will be equal to angle RPQ. So their corresponding parts are equal. Now can we say that AB is equal to QR? No. We cannot say this if it is written that triangle ABC and PQR are congruent. Now if we have to equate different pair of sides or angles, then we may have a different terminology, different way of putting it, and we may actually say ABC is congruent to triangle QRP. Now if this is the case, then we can say that AB will be equal to QR. So when we are writing that these two triangles are congruent, we denote this triangle accordingly. When we are saying ABC and QRP, then we are saying AB is equal to QR, BC will be equal to RP, and AC will be equal to QP. And similarly, angle A would be equal to angle Q, angle B will be equal to angle R, and angle C will be equal to angle P. So this notation is important. When we say one triangle is congruent to other, the notation makes a significant difference as to what would be the corresponding parts. So friends, now that we've discussed about congruency in general and congruency in triangles in specific, now let's try to see where is it used, what is the application of this congruency in triangles. We'll try to understand with the help of an example. Now in complex geometrical figures with some known dimensions, Congruency may be very helpful in finding some other unknown dimensions. So if there's a very complicated geometrical figure given and some of the dimensions are given, say some of the angles are given and maybe some of the sides are given, and we need to find the remaining. So in some of those cases, it is very helpful to apply congruency in triangles to find out the unknown angles or sides. Now supposing we take a right angled triangle and we call it ABC. Now if this BD is drawn in such a way that it divides these two triangles into congruent triangles. So we are saying it is given to us that triangle ABD is congruent to triangle CBD. Now can we find out the different angles and the angles of this triangle? Now since we know that ABD is congruent to CBD, we know that we use CPCT for the congruency of triangles, and we say that this would mean that AD is equal to CD, BD being the common side, and we can say that angle ADB will be equal to angle CDB, and if these two angles are equal, they have to be 90 degree, because the sum of these two angles is clearly 180 degree and these two angles are equal, so that means each one of them has to be 90 degree. Now since we know that these two triangles are congruent, we also know that AB is equal to BC, right? So if we have AB is equal to BC, we know that these two angles will be, first of all, these two angles will be equal, and then since the sum of these two angles is 90 degree, these two angles will be individually 45 degree each, this being the 90 degree angle, because we had this originally as a right angled triangle. So now just by knowing that these two triangles, this line is dividing these two into congruent triangles, we knew all the angles of these triangles. So this is how congruency of triangles is applied to the complex geometrical figures. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.